Howdy cow folks, Mr. Norman here. So we're going to go over lesson 1.1 inside of our honors geometry class. So this section is very reliant on vocabulary. Heads up, our quiz this week will basically be a vocabulary quiz. So we're going to start off with three terms. They are undefined. What undefined in this context means, it's not they don't have a definition, it's that there's not a formal one. In mathematics, we have things that are formally done and informally done. Formally means there's a very specific, very strict, very official way of understanding it. You may remember this from previous mathematics classes. The definitions in math can be tedious, can be aggressive, can be a lot. That's because all of those terms are defined. As we'll see from our three undefined terms, the definition is a little vague, which is pretty rare in math. A point has no dimension. A dot represents a point. So we know from graphing that a dot is just a point is just a dot on a map. Don't save. A point, a dot, boom, random point in space. That's all we have, whether that be a graph or a point in space. Have a dot. In geometry class, we rarely have a grid. That's one of the big differences from algebra. So these are a bunch of points, which are dots. So then we have a line. We're pretty familiar with a line. A line is a one-dimensional. It has one direction. Point in space. And dots, points can be found on a line. And if we notice, we have this thing called an intersection where two lines meet are points. Go back to our title. So typically, we're used to seeing it with two arrowheads. Note the proper way to write line is with the two points upon it and an arrow. Oh yeah, get nice and close in there. Two arrowheads going both directions. This represents a line. When you have a line, it doesn't matter which comes first. I repeat, when you have a line, it doesn't matter which comes first. You can also write a line by putting a cursive letter to represent it. The next one is a plane. So through any points not on the same line, it's a plane. We can think this sort of like a wall or a sheet of paper. So in this context, put three-dimensional graphing calculator. A plane is between any three points. So this is a plane, flat sheet, going up, going down, going through. Any 3 points creates a plane. Boom, we have another one. So like I said, it's a bunch of sheets of paper. Notice that the intersection of two planes is a line. And it's a line all the way down and across. So we have another funky plane. Co-linear points. Same linear line. So they're just points on the same line. So I, H are collinear. I, H, K, all these are collinear. K and N are not collinear because they're not on the same line. Pretty straightforward. Coplanar points, they lie in the same plane. So for this purposes, all of these items are coplanar because this one sheet that we're looking at is the plane. Go to this calculator. This graph creator. A and C are on the same plane as it goes up and down, but A and B are not because they're on different planes. So these items are coplanar. D, H, G, I are coplanar. H, E, it's also on the same plane. Oh, made a funky plane. Look at all those intersections. So these items are coplanar, while these are not. So, example, this is just giving something to practice. So give two other names for line PQ. Two arrows, means line and plane R. You know this is plane R because there's a capital R here, indicating it's a plane. So we can name a plane with any 3 points. So this could be plane T, P, V. There are many options. We could also, we need 2 names. So this is also going to be plane S, V, T. We know the name for line P, Q. So it's also going to be line in, because that's what this little script in means. Or we can have line QP because the direction doesn't matter. Now name 3 points that are collinear. Okay, 3 points on the same line. S, P, T. Done. Name 4 points that are coplanar. Oh, these are the boys down here. They're coplanar. Yeah. And here's some options for the solutions. Using the diagram in example 1, that'll be this one. Give 2 other names for ST. Name a point that is not coplanar with points Q, S, and T. So I'll give you a moment, pause the video, and write down your answers. Do your best. And when I get done with the jump cut, you'll see the answers. So the highlighted portion is the correct answer to monitoring progress 1. If you got it incorrect, don't worry, you'll have a chance to redeem yourself with the practice problems later. If you have any questions or any confusion, please email me at anorman@nisd.org. You can communicate with me also through Remind and through Google Classroom. Now we're going to define terms. These terms are going to have a much more specific definition. They're going to be a lot more exact. So the words we're going to have defined definitions for are segment and ray. We'll start off with a segment, or a line segment, or a segment. Segment consists of endpoints. That means it has 2 points at the end. That means it's just not going forever. If we notice the way that it's written, a line has 2 arrows. A segment, or a line segment, does not. Just like a line segment can be written in any direction. A ray has an endpoint and goes on forever. An endpoint and goes on forever. An endpoint and goes on forever. Unlike line segments and lines, the way you write a ray matters. AB is not the same as BA. They point in different directions. Notice also the typical way to write a ray is for the endpoint to be listed first, then the part that continues. And then we have opposite rays. An opposite ray, simply put, when you have a line, if you have 3 points, you create opposite rays. You have ray CA and ray CB. If we look at just this chunk, we have a ray going there. And if we look at just the AC chunk, we have a ray going there. They're opposite rays because they are rays starting on the same line and going in opposite directions. Pretty straightforward. So we need another name for line segment, GH. As noted earlier, we can go the opposite direction for HG, as shown here, and then name all the rays with endpoint J, which just means all these are endpoints. So we have arrays going this way, JG this way, JF this way, JH this way, JE. Another name, yes. So time for monitoring progress. Using this diagram, first, give another name for line segment, no arrows, KL for 3, or KP and PK, the same array, or NP and NM, the same array, and explain. So after the jump cut, there'll be the answer. Take some time, write your notes, and provide your answer, please. So the answer to monitoring progress 2, KL can also be LK. We can go other directional endpoints. Are KP and PK the same array? No. KP, this is the endpoint, and it goes on. It starts at K, goes on forever. PK starts at P and goes through K forever. Second one, yes, NP starts at N, goes through P forever. So it means that includes everything the N will touch. Oh, yay, rain. NM is the same thing as NP because it continues going. Our NP and NM. There's the explanation. So, another jump cut, and we'll be back to the lesson. Like we covered in GeoGebra, we have intersections. That's where two geometric figures or objects connect with each other. So the intersection of two lines is a point. The intersection of two planes is a line. Remember, this is for unique items. So if line N and M were the same object, they would just overlap. But we don't care about that version. So then here are examples of each of those things. A plane and a line, a plane, and the line is in the plane. So the intersection of the line and the plane is that line. A line and a plane that do not intersect. They don't touch at all. And then the line goes through the plane at a point, so it just has that one area right there. So we can go back to GeoGebra, clear all, don't save. So here, if we make another plane going a slightly different direction, so we'll have 1, 2, 3, we have a nice vertical plane. We see that this line, this green line, goes through it at one point. We see that this red line goes through the plane the whole way through. We could have a line out here that wouldn't touch this line at all. And then to intersect, so then we have, boom, the explanation of what's happening here. So monitoring progress 4, sketch two different lines that intersect a plane at the same point. Then, using the diagram, name the intersection of P and Q in line K, name the intersection of plane A and plane B, name the intersection of K and plane A. So there'll be a jump cut, and you will see the solution. Please follow along in your composition book. So here's an example answer for 4. So two lines that intersect a plane at the same point. Boom, boom, they cross. The answer to 5 is M, right here. Answer 6 is line K, because the intersection of plane A and plane B is line K, and the intersection of line K and plane A is line K, as discussed earlier. Jump cut. So this example is going to walk us through the thinking process of a word problem. It's also showing us a sulfur hexafluoride molecule, something you may recognize from chemistry class, the name. So we need to name two different planes that contain line R. Here's line R. Remember, a plane is three connected points create a plane. Any three connected points make a plane. So the solution, first we need to understand the problem. We need to name two different planes, make a plan. The plane should contain 2 points on line R and 1 point not on line R, because we need two planes, 2 points that are on line R and 1 point not on line R. Otherwise, instead of having a plane, we'll have a line. So solve the problem. We have D and F. They're on line R, and E is not. So we'll create a plane here. So then we can go with the other direction. Or to go back to GeoGebra, the phosphorus, we can have 3 points. So this is a line. This is a line, B and C. We pick 1 point not on it, and we have a plane. We'll pick 1 point not on it. It's the same plane. So we'll pick another direction. That's a plane. Oh, sorry. We need to be intersecting with the red line. So let's create a plane. 1, 2, 3. What a funky looking plane. So we're able to solve that one. 3-dimensional. Figures are fun. I will send you a link to the 3D calculator and the 2D calculator so you can play around yourself. Back to the example. You can finish this reading this yourself. It just explains some more thought process. Here's monitoring progress of a similar thing. This one is phosphorus pentachloride. So here are some answers to the monitoring progress. Since there are multiple points, we can have multiple answers. That's why it says sample answers. If you have any questions, please email me. Mr. Norman out. Peace.